recording. Okay, welcome to our session on strategies for teaching introductory astronomy. This session is sponsored by the Organization for Physics at Two-Year Colleges, also known as OPTYCs, and we are from the PER interest group. Our goal is to share interesting strategies, materials, information from the Physics Education Research community, share that with people, and just basically get people involved in that community. So as a result, we try to give a lot of different topics. I do want to share with you some things that we have coming up in the future, just so you know. Related to this session on November 2nd is a workshop on using JS9 with students. JS9 is it's a web-based, browser-based application that uses real data from NASA and other places, real astronomical data, and allows students to actually do analysis, do investigations with that software on this real data. I had the opportunity to attend one of their workshops at the last APT meeting, and I was very impressed with the ease of use and the power that is available for using that for students. So we're very, very excited about that workshop. That's next Saturday from 1 to 4. We also have an optics town hall coming up as we are moving into our last year and a half of our grant. We are planning for the future, like what happens next as far as funding and as far as what will we offer in the future. We want to make sure that we're offering what the community wants. So there's a town hall, a chance to discuss what optics is doing well and what you'd like to see in the future. And then on December 13th, there is a PER session on assessments and equity. How can we write assessments that are more equitable and meaningful for our students? So that is on December 13th from 3 to 4:30. We also have some big program type things coming up, some deadlines coming up. We have an all-day sensor-based physics tools workshop, which is going to be held at the AAPT meeting in January. That will be in St. Louis. And the application deadline is coming up November 1st. But I've been told by the people who are handling the registration that if you really would like to apply, just send optics an email, even if you can't get your application in. And on November 1st, you need a few more days. Just give them an email, and they'll make sure that that application slips in there. We also have a 2-day intensive immersion experience on creating environments that reach every student. This is making sure that all of our students, regardless of their background, regardless of their experiences, have a chance to succeed. So it's a 2-day workshop looking at what strategies we can use to help reach every student. Our new faculty development series, which is officially for people in their first 7 years of teaching at a 2-year college. That is a multi-day experience. The people who've gone through these previous workshops have found it to be incredibly valuable. Those applications are opening in January 2025. So if you are a new faculty member or know someone who's a new faculty member, I encourage you or them to apply to that. And then the 2-year college tandem meeting, which is a 1-day meeting held in conjunction with the AAPT summer meeting. Is coming up. You just register for that at the same time or in the same place as you register for the AAPT summer meeting. You do not have to register for the full meeting to attend the tandem meeting. So if you can't manage, that 3 or 4 day meeting for AAPT, you can come for the 1-day focus on 2-year college issues. They'll be sharing, there'll be workshops, talks, lots of good stuff going on there. So we have a lot going on. So I just wanted to make sure I shared that with you. As far as today's session goes, what we're going to be doing, let me just share with you what's going to happen. First of all, I'm going to give a couple of strategies that we found in the literature. in the astronomy education research literature that are just, we found them interesting and we thought we would share them with you. And after we do that, we're going to open up the rest of this session to sharing and discussion. In other words, this is an opportunity for you to share what you found works, so that everybody gets a chance to share some good stuff, because we know there's a lot of good stuff going on out there. And then we have, of course, a very brief evaluation, because National Science Foundation, who ultimately funds the things that we do, likes to see evaluation. So that's what we'll round up with. All right. So any questions, comments? All right. Well, then let's go ahead and get started. I am providing QR codes for the articles that I am talking about here. So if you want to grab that QR code so that you can look at the article later, feel free to do so. The first article I'm going to talk about is an article by Gozzard and Zadnik, which was published in Physics Education, or excuse me, Physical Review, Physics Education Research. Just a few years ago. It was published in 2021. But this article talks about the use of naked eye observation journals in an introductory astronomy class, and it about how they got the students to make these naked eye observations and keep a journal of it, and they researched the effect on the students' understanding and engagement and attitudes towards astronomy and science in general. So it was a really interesting little article. And I'm just going to review very briefly what they found, just so you know, hey, maybe this is something I want to look at. Maybe this is something I'm not so interested in. So basically, the students were required to keep naked eye observation journals over a 13-week period. They were required to include drawings or photos to document their observations. They were required to record data and then to do some analysis of what they were doing. The journals included some required observations, and I've listed them here. The position and time of 4 sunrises and 4 sunsets, 4 planetary position observations, and 1 per week for 4 weeks, basically to document the path of that planet against the background stars, and then 4 consecutive night observations of the moon. The format was left to the student. The idea being, if the student is allowed to have some creative license with this journal, that it would increase their interest and engagement with the material. So there were some people did hard copies like a regular lab book. Some people actually did a web blog. Some people did a digital lab book like in OneNote. Some people did PowerPoint. There was a lot of different strategies that the students selected. And then they were all provided with a grading rubric to guide their efforts. And I did make a copy. Ooh. I did make a copy of the rubric that was provided. This is what they did to grade it. They did say, however, in the article that they found that this was a little bit too generous. And so they actually did modify it slightly toward the, after the study, but there were no results given for that modification and how that affected it. So that was that particular thing, that particular approach or strategy to teaching intro astronomy. So what did they find? What was the result of using these journals? Well, they were assessed using 2 instruments, validated instruments, the Astronomy Diagnostics Test and Attitudes Towards Astronomy Survey. If you are not aware of where you can find these validated instruments, Physport is a website that is run by AAPT and other agencies, but it has a database of validated instruments for assessing students' understanding, not just in astronomy, but in physics and in attitudes and those kinds of things. So it's a good resource if you've not used that before. Using these two instruments, they compared students who created these diaries with those in a similar course with no diaries. And they did find a moderate increase in students' understanding of basic astronomy concepts. But they did find a very significant increase in positive attitudes towards astronomy for the students who did these diaries as compared to those that did not. And the students who did these diaries appeared to engage more with the material. And then finally, they said, not everybody liked this. Okay. Some people felt, like they were being forced to go out and that it impacted on their free time and that kind of thing. But many, many students did express that they did enjoy it. The majority, they said. They did find a significant number of students, about 16%, submitted observations from astronomy apps rather than their own observations. They did point out, though, that these are fairly easy to tell because sometimes they would, for example, provide observations that were not possible to see in their hemisphere. So it's pretty easy to catch them at times. And then some students had difficulty analyzing and interpreting the observations. Like, what does it mean if a star traces a almost straight line path rather than the arc that they expected? What does that mean? They had trouble analyzing that. And they also found little correlation between diary grades and exam grades. But they did note that this might be a benefit to students who struggle with traditional assessments. So I'm going to pause right there and just open it up to discussion about this particular strategy. What do you think of this strategy? Positive, negative, interesting, not so interesting, fraught with issues? What do you think? Is it something that you might be intrigued to try out?
I mean,
I,
I
well,
I will say we don't offer astronomy yet, so I'm trying to get some ideas. And this seems like, a good way to start, seeing as how we don't have telescopes or equipment on hand.
Yeah.
So this could be something that we could
Yeah.
try. I'm curious how, it's extended cloudy nights, how that's handled or things like that.
They did mention in the article that in the case of extended cloudy nights, they were allowed to use an app, but they had to document that they did so. And of course, it had to correlate with the actual weather on those dates. Edward, do you have your hand up?
Did they give any indication of how much of the course's grade this was attributed to?
Yes, they did. They mentioned that when they did this the first several semesters, it was 5%. And they had decided at the same time they changed the rubric. And again, they published this article before they had a chance to try the new rubric and the new setup. They did indicate that when they changed the rubric, they planned to make it a larger portion of the grade. But I do not remember off the top of my head
Did they
what
also
that
indicate,
percentage was.
did they at all indicate that they felt that in the next iteration they should have them do more? Like it wasn't enough, like they should do more moon phase, observations or more sunsets or anything like that?
They did not make any indication in the article of that.
Okay.
I can, if you would like, I can put that QR code back up there if you're interested, if you would like to get it. This is a freely available article. In other words, this is one of the freely available articles in PhysRev PER. So all you got to do is just get there and click PDF and you've got the article. So I'll leave that up there for a second while we're chatting. Other comments?
So this is Noella. Can I mention that I sometimes ask my students to do like moon observations for extra credit. So I'm teaching a lecture only astronomy class. So there's no lab, but I do ask them to look at the sky. Sometimes I think I have many years ago asked them to look at the path of the sun. But these days it's mostly, and that was again, extra, extra points. So yeah, sometimes, like they will draw a gibbous moon as a partial lunar eclipse moon. And I do, tell them that, these are some of the pitfalls. So try not to make those mistakes as you're doing this. So yeah, just to kind of tell them to keep looking at the sky, to connect with what things we are doing in the class that are easily observable with the naked eye. But then just like moon observations is what I nowadays do for extra credit.
There was some comments, student comments provided in the article, and it's one of the things that was mentioned was one of the students had said, I never realized how much I was missing by not looking at the sky more often. So your comment kind of alluded to that. Keep looking at the sky. Edward.
I was going to say, Robert, this is sort of providing a little feedback to something you said about, not having a telescope. I happen to be at Stewart Observatory. We have the public telescope in the courtyard right outside my classroom. I request students to go make an observation, but here's what I want to say. That sounds great. It might actually be a curse. By and large, my students wait way too long into the semester to do their observing project. And I talk about it all semester long. I'm like, you're procrastinators. What are you doing? Like, how could you not? By the time the end of the semester gets here, there aren't even going to be enough time slots for you to be able to sign up for one because you all wait. Because it's there, it's like a night of observing, not many nights of observing that's required, right? And I think it's actually, I'm looking at this result and I'm like, maybe I should not have them do a night at the telescope and let that be something they can do on their own time and suggest that they do, and do something that is more naked eye astronomy and make it due midpoint in the semester. Because there's enough days to do this level of observation already, having, gotten earlier in the semester with the idea that they might choose to go to the public observing telescope that's on campus as a result of having done this. But there's no equipment. Like having that piece of equipment in the courtyard might actually not be such a great blessing after all. Like the naked eye might be the way to actually do it. And the real reason I'm thinking that way is they need to do repeat observations. They don't really get in the night that I have them do observations, anything about change, anything about path, anything about any of the cool other things that they should have to then kind of deal with from an explanatory standpoint in the observing project. That idea of having to try to draw and explain and generate information about it, that's something they're not doing a very good job of in the current version that I'm doing. They make a drawing. It's just dots. It's like, oh, they cluster dots, or bad nighttime. Oh, there's this one planet. They make some kind of crap. I just think this has a little more teeth to it than what I'm doing. And I think since I have a portfolio that they turn in at the end of the semester, this could go in their portfolio and have meaning. But I do think I would do it so that it was due quite a bit earlier in the semester. I also have like several hundred students, so I'm thinking about the grading side of this. That rubric might seem a little low level, but that's fast. You could do that rubric. And I think you could be pretty consistent with that rubric. It's kind of like it smells like poo, doesn't smell like poo. It's got those kind of scales to it. So
Right.
Thank you for bringing this up.
Uh-huh. I just happened to your comment about making it due early. They did say that this was due 3 weeks before the end of the semester in their case, so that would give the time for feedback. And they also mentioned that those required observations were done early, very early. They actually had an early deadline, and then the professor would look at those required observations first and give them feedback so they would know, are they on the right track with their observations and their analysis and their data. So it's not like they never got any feedback during the whole semester. They had that building process and feedback loop so that they knew that they were on the right track or not.
I actually had a question about the rubric.
Yeah. You want me to go
see-
back to that?
Yes. So
There you go.
you said that it was too generous. Do you mean that it outlined too much of what they should do?
No, they felt that it did not clearly distinguish between students who did a really great job and students who just did an okay job. They said it was good for distinguishing the people who really clearly didn't do what they were supposed to do. But there was not as much distinction between the people who did really well and the people who did okay. And they did change it, and I'm sorry I did not copy the new rubric. I probably have it right here, but what they left these first three things the same, but they changed these bottom two. Let's see if I actually have it here. And if I have it, I'll just do it as a real quick screenshot of that PDF so that you can see the new one. Let's see, that would be under astronomy session. There we go. And this was the paper I got. There it is. Look at there. I do have it. Oh, nope, I do not. Oh, yes, I do right here. All right, so let me go ahead and slide that down to that page, and I will just share that with you so you can get an idea of how they changed it. Let's see, that's the new old one, and they do have, there is a lot of data in this paper. So, you know, feel free to dig into the data or just, you know, get to the how did they use this and what were the results kind of a thing. All right, so new share right here. Okay. All right, are you seeing the paper? Yeah, so if you look, this is the stuff that they changed right here. These are pretty much the same, and these two were changed. Oops, let me move that over. Yeah. So not serious changes, but they felt that this might better distinguish between those mid-grade journals and the really higher journals. So
It's interesting that even in their changes in the upper categories description, it doesn't provide a distinction like included a detailed ... It just says included or didn't include. Even their own categories make it seem like you can only choose maximum or minimum.
yeah,
Like,
yeah. And again,
weirdness.
you know, that's the beauty of rubrics is that you can, you know, tweak them to your own needs and your particular situation. So
Did they in the star the survey instrument about attitudes in astronomy,
mhm.
did they get into the weeds about which attributes in that survey instrument this attended to more or less, and which things it wasn't attending to more? Was there any kind of like analysis? I haven't seen this paper, so I don't.
Yeah, there was quite a bit of analysis. I mean, if you, again, I'm just going to scroll back here and I mean, you can see here analysis and analysis. And so I didn't get too far into the weeds of the analysis because I knew I was just doing a quick summary of this. But you can look that they did, for example, break it down into from this astronomy into how did they view astronomy? How did they view science as opposed to astronomy? Because they did mention that they found that some students thought astronomy was different from science in some way. You know, so they did break it down a little bit in that respect. I'm going to go back to my other slide. Okay. Back to here. Okay. Any other comments about this before we move on to the second approach? Okay. Let me go ahead then and we'll get over to the new one. This article is from the physics teacher, which is a journal from AAPT. Again, there's a link to it. And this is an approach, basically the title says it all. Less is more in introductory astronomy. But what I found interesting about this, I'm still trying to decide if I like this or not. But it was interesting and it was different. I thought, well, this is worth talking about and discussing and sharing. So basically what they did is they used a combination of ungrading and mastery. Both of those approaches have been getting a lot of talk in the physics education community lately. And the interesting thing about this approach, and oops, was the course structure. They started by the instructor basically covering all the topics, just like they would normally do. So they did not change the presentation of the course material in any way. Then they gave many, many low stakes, like multiple choice type assessments on these topics. And we all know that if you're just doing nothing but multiple choice, it's a pretty low level assessment. You know, you're really not gauging fully understanding, you're really gauging recall. Then students chose topics that interest those. Out of the topics that the instructor presented, the students chose topics that they were particularly interested in, and they were then assessed at a slightly higher level for those familiarity topics. These are topics that the student was going to study more in depth and read more about. If they successfully completed this and nothing else, their grade was going to be in the CD range. And they knew this ahead of time. Okay. Then the students chose topics that they were going to be proficient in. And these exams were more of written type things, analysis, explanation, much more in-depth questions, virtually no multiple choice and almost all written and analysis questions. And if they successfully completed that, they were going to be in the CB level range. And again, the students knew this in ahead of time. And then finally, if they really wanted an A in this course, they had to create a mastery project on one of the topics they had chosen. And the mastery topics, I'm going to go ahead and switch to what the mastery topics were. Oops, I'm sorry, I skipped a slide. Let me back up. There they are. The instructor covers the usual topics, as I said, and their mastery topics were based on a question. And how would you answer that question? And they could do this in an outreach point of view, an observation point of view, or a simulation point of view. And then that, of course, was expected to be a longer term project, something they've identified early on as interesting to them. And it involved a lot of back and forth with the instructor. And they found, oh boy, sorry about the typo there. They found that the level of student engagement was much higher. And they were able to really get more from the course than they would just doing the usual type of assessment that we would typically do in our intro astronomy course. And what was interesting about this particular group is they actually used some typical instruments like the force concept inventory and used it with their astronomy students. And they found that their astronomy students were learning the basic physics ideas that we would hope that they'd get out of an intro astronomy course, just as well as students taking an introductory physics class, an algebra-based physics class. So it was really an interesting little approach. Again, I haven't decided what I think about this yet, but I thought it was interesting and thought it was worth discussing. So with that in mind, what do you think?
This does sound like sort of a novel spin on the mastery grading, the I don't know, just kind of how the idea of grading is sort of opening up. I'm curious about how much work this was for the instructor to support the students through all these different things. That seems kind of daunting.
What I gathered from the article, and this is in the Astronotes column, so it's a short article. It's a very short article. It's 2 pages. Unlike the other one, which was multiple pages. And they did say that, you know, as far as going up through the proficiency level, it really wasn't a whole lot more work. But of course, the mastery level required multiple meetings one-on-one with the student to determine, you know, what should the question be? What's an appropriate question? How do you go about answering that question in a reasonable manner? In other words, in a manner that's appropriate to the question and to the application. So in that respect, I would say that probably was a lot more work. When I reflected on that myself, I thought about, well, when I taught introductory astronomy, I rarely saw those students. But when I taught calculus-based physics, I would see those students all the time. And so I thought, well, really, based on what they're saying, they're probably seeing now those introductory astronomy students about as much as I was seeing my calculus-based physics students. Is it more work? Yes. But is it beneficial to the student? You bet it is. So that was kind of like, okay, I can see that. But again, yeah, probably a little more work. Other comments about this or questions? Would anybody like me to put that QR code back real quick? Or are we okay? We get it? Get it already? Okay. All right. So we've already talked about our thoughts on these approaches. So now we have open discussion. What kinds of things do you do in your intro astronomy courses? What are your favorite strategies or materials or anything else? And what activities that are you finding are particularly useful for helping students understand or engage with the material? And for Robert, I think this would be a great discussion since they're getting ready to do astronomy and haven't got the course up yet, but ideas are always helpful. At my institution, we had we were very fortunate in that we had a planetarium on campus, and so our students would regularly either have assigned viewing and typically during class time to make sure. Again, you know, 2-year colleges are often commuter institutions and students work and have family and things. So we would have scheduled observations in the astronomy at class time during the semester, but they also would get the opportunity to have extra credit. If there was something going on at the planetarium and they went, they would get extra credit for that. And I was kind of smiling to myself when the comment was made about students are waiting to the end of the semester and then to go to these extra credit observations. Yeah, we saw that too. So, but we did find that getting the students in the planetarium, even though it wasn't really the sky, getting them to look, to see that helped the students engage a little better with the class material. So that was my example. How about yours? How about the rest of you? Do all the rest of you already teach an intro astronomy course? Yes, Maria. Oh, you're muted.
Thank you. I actually teach an astronomy class online right now, but I will probably have to do it face-to-face very shortly. So I'm kind of trying to prepare to see how I'm going to accomplish that. For the one thing that stood out in my online astronomy class was discussion boards on really contemporary subjects like, what do you think about rich people going in space when the rest of us cannot go? Something like that. So I have created a short list of students of topics that students were interested in. At the end of the semester, everybody said, well, their favorite thing about the class were the contemporary subject discussion boards.
Mm-hmm. And that's something that's shown up in the research as well, that students are really interested in the modern, cutting edge, exciting ideas and stuff. And that's not just in astronomy, but in physics. And how can you talk about those high level applications and really cool cutting edge science things when they don't have a firm background on the rest of the science that's behind them? So that's a challenge. I will point out that in the chat, Edward has put some resources, which I think are very useful. Arizona does have a pretty solid astronomy education research group, and so a lot of materials come out of them. I see that you've got a list there from Arizona, and some other interesting things. So thank you very much for putting that in there. We appreciate that.
Yeah, I also put something at the beginning of the meeting in chat, and I'll put the actual URL in. So I'm Ed Prather. I'm at the University of Arizona. I run the astronomy education group there. And I also do professional development workshops around the country. I may have met some of you at some point in your careers in that workshop. I don't know. But there are some workshops that are just for astronomy teaching that you might be thinking about doing that are not just at the AAPT meeting, although they happen at AATP meetings, and I suggest you seek those out. But if you find yourself at a AAS meeting, there's also workshops there. There's also a new workshop program that's an AAPT, APS, and AAS collaborative workshop series called Faculty Teaching Institute. It's a 4-day long workshop. It's run by physics and astronomy education folks. It used to be called New Faculty Workshop. And highly suggest that if you want to know more about going deeper on creating an equitable and inclusive and active classroom, that you think about that. 1/3 of all participants are two-year college folks now. So we're getting a greater and greater number of two-year college folks coming to it. I've always had programs with an eye on two-year colleges because I started off at a community college. That's where I got my start. And if it hadn't been for a two-year college, I don't think I ever would have made it. So I'm very much about supporting that. There's also work being done. Sherry shared information about different approaches. One about the work that's being done at Space Science Telescope Institute about bringing data into the classroom. Rubin Observatory is coming. It's like there's a tsunami coming. And that tsunami is going to overwhelm all of us with data. And I work for the education program with Ruben to design investigations to try to make data more accessible to novice students. And we have a series of investigations at Ruben Observatory Education that have been tested and are in development to try to bring different data sets. And since we don't have our data yet, we're using precursor data from other missions to build the investigations now. And as Ruben data arrives, it'll replace that data. But they're free, available. All you need is a browser. Been tested in a lot of classrooms already, still being developed. Some are kind of in a beta shape and some are a little further along. But if you're curious about them, I'm going to put the link up here in a second. I put a link up there to Zooniverse, which is a way of doing citizen science projects with your students. And I also put a link up there for the materials developed by Kevin Lee at University of Nebraska-Lincoln. He has the largest selection that I know of simulations and animations to teach astronomy with, and then also an incredibly large collection of think, pair, share questions that you could also have for using questions in the classroom to do feedback while you're in lecture.
Excellent. Excellent. So between the astronomy things that optics has in the pipeline, some of them are still in development, so I didn't put them on my slide. And the things that he has mentioned, that Edward has mentioned, there's a lot of opportunities out there for getting good stuff for astronomy. Other things that you are doing or questions you have about what you would like to do in your classroom that we could address?
I teach high school astronomy. I teach an introduction to astronomy class, just a semester long science elective for our students. And I'm always trying to figure out how to bring the concepts, you know, to an experiential kind of level for the students, right? Because we don't have a planetarium and we don't have, you know, really powerful telescopes or anything like that. One thing that I always go back to that I find super powerful in an astronomy class that I took when I was working on my master's was the, you know, the light bulb in the middle of the room and everybody's got a ball and doing the phases of the moon. I was, I don't know, in my mid-20s, and all of a sudden I was like, oh, that's how it works. Like that's something that I would never, ever, ever skip with my own astronomy students. I make them stand up. They're high school students. They're seniors in their last semester. They're too cool to hold the little foam ball, but I make them do it because, oh my gosh, does it finally make sense why the moon is like up there right now, kind of a thing. So anything where I can get them experience in a classroom usually is what I'm looking for.
That's awesome. That's awesome. I love that activity. Yeah. Other cool activities.
Hello, Professor.
Hello, welcome.
Thank you. I'm Abdurrahman Al-Arabi from Morocco. And I have a master's degree in quantum information. And now I start in my PhD thesis. I research about my PhD thesis. And for that, I do some activity like I make some workshop with our friend, but the problem in our university we haven't the absence of the experimental part of our projects. Thank you.
Okay, thank you. You know, your comment about, you know, not having a lot of powerful telescopes and things, just share a personal experience of, you know, you don't really, you know, there are things you can do observationally, which kind of takes us back to the first article that you were we were talking about, that you can do with the naked eye or a pair of binoculars or even just a terrestrial telescope even. we went out on the hill behind our house. We're kind of out in the country, so it's dark. We get a little bit of light pollution, but it's not as bad as living in the city. And we wanted to see the comet. And, I got out my Star Guide or Sky Guide app, and I'm looking, okay, it should be right there. And we're looking and we're looking, we're waiting for our eyes to adjust, and we're looking and we're looking, and we're not seeing it. We're not seeing it. We're not seeing it. And we're like, And so my husband ran into the house and got the binoculars. And there it was. There it was. And it was just the coolest thing. And, here I am. I've taught astronomy. I have degrees in physics. And to have it feel so exciting, I just, to share that with the students, how much more exciting would that be to the students? Something as simple as that, um, and it was just a pair of binoculars I used for looking at the birds out in the trees around my house, nothing fancy. So just don't be daunted by the fact that you don't have that equipment. There are ways to get students to experience that wow factor, even without a lot of fancy equipment.
Yeah, no, I appreciate all the great ideas. I do like that the naked eye approach. I think that'd be great for our students. I definitely like the flexibility of it, for our students who, like you mentioned, have a lot of other constraints and such. And yeah, I like the idea of the contemporary discussion boards. I live where we're at is about 25 miles from where SpaceX launches. And that's been sort of an interesting experience. So it has spurred, all kinds of interest. But when those launches occur, like everybody's house is shaking, and it's something I guess people were not expecting. So
Yeah.
so yeah, there's I think there's overall enthusiasm, but there's also some kind of like maybe some questioning going on as well.
Mhm. And to kind of follow up on that, where I taught was in Central Florida. And if you stood at just the right place on campus and looked east, you could see launches as they were taking place. And so one of the things that we did is, the student, if that launch happens to be during class time, we'd all troop out and watch the launch. If it wasn't, you encourage the students to watch it, and then you tie in that launch and where it's headed. Is this a probe? Is it a satellite? Is it ever? And then you can talk about either the astronomy. Is this a probe going to an asteroid? Well, let's talk about asteroids. And what do we know about asteroids, and what are their paths, and what governs the path they take? Or if it's a satellite, we could talk about orbits, and geosynchronous orbits or polar orbits or other kind. So it gives you a chance to tie in the topics that you're actually wanting to teach anyway with something they can see right there. So that's something that would be really cool to do if you are in a place where you can see those launches. And even if you're not, because sometimes, especially if it's the bigger launches, just go on the NASA website, watch the launch, and there it is, and you can tie those topics into what that particular launch is going to do. Great ideas. Other stuff that you might do in your classroom. Yes, Noella.
So I just wanted to say I also actually use some of the materials that Ed's group has put together. So I use the lecture tutorials in my astronomy 101 classes, though I've had to kind of, I teach at a community college at Joliet Junior College, and so I've had to kind of make some some kind of go a bit slower than I would with these lecture tutorials, because my students tend to need a little bit more hand-holding at the community college. So, I do try to help them out with a bit more than I would otherwise do, like when I've taught at a university. I do also use a lot of think, pair, share questions in my classes. I think that helps me a lot to get feedback right away from students. And as Ed mentioned about Kevin Lee's materials, I use those also a lot. They're really very nice. And I do encourage my students to use some of them to help them, practice with the materials as well. I also try to show, like astronomy picture of the day, pictures in my classes as often as I can. And I do use, at least in one discussion group in my online class, I use astronomy picture of the day pictures in that discussion to help students learn more about different astronomical objects and relative sizes and how far away they are and things like that. So
yeah, that's a great idea, the astronomy pictures of the day. That is really wonderful, which leads me to another thought based on images. We love to show those images of, the cloud forming, the planet forming clouds, and all these wonderful images that are coming from the different space-based observatories. But there's also a lot of value, I think, in showing just images of what the sky looks, a dark sky, what it looks like on Earth, from with the naked eye. I think there is value for that. And the reason I say that is I had an opportunity 10 years ago or so to teach in China for a summer. And one of the courses I taught was an introductory astronomy course. And this was in Beijing. And I was showing pictures of just the dark sky. I had the Milky Way. I had some dark sky images were taken from northern China. It's just some other places. I tried to connect it as much as I could to their part of the world. And I realized that there were some people there were just, some of the students were just like, their mouths were almost hanging open at these pictures. And one girl finally said, I didn't realize the sky looked that way. These are students who lived in the middle of Beijing. Even when the sky was clear, they saw a few stars. And when I say a few, they might see the 5 or 6 brightest stars, and that's it, because there's so much light pollution. They had no idea what the sky looked like. So to show those images of a dark sky, which so few people get to really see those really dark skies. I think even that is a very powerful thing that we can do in our classes. Anything else that you would like to share about cool things you do in astronomy or things you'd like to do? We're rounding up to the last 5 minutes or so of our thing. Edward,
Yeah.
would you mind when we post the recording of this session, could I share the links that you have provided on our YouTube channel? Okay, thank you.
I'm gonna add the FTI in there so that if anybody's interested in getting some more professional development on this, they know where to go.
Okay, awesome. And like I said, I also encourage you, if you are interested in something, no equipment required, browser-based application that can actually analyze real astronomical data with your students, and at anywhere from a high school level on up. The presenter actually does it with high school students, and there was other people who have used this with college level and university level students. If you're interested in just seeing what that that application does. We do have that free workshop coming up on November 2nd. I encourage you to sign up for that. Okay, thank you for the Fizzport link. That Fizzport link is also on the optics website as well. Okay, well, the last thing that we have to do, let me go ahead. First of all, the reminder of the upcoming astronomy workshop. If you would like the link, I've got a QR code there to the registration link. So that if you want to get there really quick, that's the quick way. You can also just go to the optics website and go to the upcoming events, and there's a link there that'll take you to the registration. And then finally, we appreciate that you came. And we would like you to please take a few minutes. It's literally, it's like a 3-line application or feedback form. Please evaluate us. Tell us what you thought. Tell us if you found this useful or interesting or both. And we really appreciate that you were here. Any last minute comments? All right, I am going to stop recording.
Hello, bro. Hello.
Yes.